All right, this question says, what is the concentration of a solution in parts per million when a sample is found to contain 5.1 milligrams of lead in 1.250 grams of solution? And there's a couple different ways of thinking about parts per million. One is milligrams of solute per kilogram of solution. The other way is the way that your book does it, which is ppm equals the mass of the solute in grams divided by the mass of the solution in grams times a million. So 1 times 10 to the sixth. So basically, we're just going to instead of multiplying by 100 for percentage to get parts per million, because percentage is parts per 100, we multiply by a million, which is 10 to the sixth. So that is basically how you can do it, or you can do it as milligrams per kilogram, which is the same thing, because then the bottom unit is a million times greater than the top unit, so you're essentially multiplying by a million. So let's take a look here at how we're going to do this. Well, if we're going to use it this way, we need to convert this one to grams. So we need to know that 1 gram equals 1,000 milligrams. So we essentially need to divide this by 1,000. So don't plug in 5.1, divide that by 1,000, which is 0.0051 grams of lead, which is your solute, the thing that's dissolved. The mass of your solution is already in grams, so we just put the 1250 grams on the bottom, and then we multiply by a million, 10 to the sixth, and when you do that, what you end up with is 4.1 ppm. Parts per million, parts per billion, parts per trillion. These are all good units for very, very dilute solutions. For example, lead concentration in water, which hopefully is a very dilute concentration.